Will Jupiter's system become habitable? How much atmosphere could the moon hold on to? Do quasars have a habitable zone? And in Q&A Plus, is transpirational cooling better than a heat shield? All this and more in this question show. It's time for the question show. Your questions, my answers. As always, wherever you are across my channel, if a question pops in your brain, just write it down. I'll gather them up and I will answer them here. All right, let's get into the questions. Try to ghost. Do you think Europa or Titan has life on it? Do you think the spots found on Mars was past life? So we have no idea if there is life on Europa or Titan or ever on Mars. The trail of astrobiology really comes from the discovery that wherever we find liquid water on Earth, we find life everywhere. At the bottoms of glaciers, several kilometers under the surface of the Earth in pockets of water, in nuclear reactors, high up in the atmosphere, in briny conditions, in incredibly hot hydrothermal pools. If the water is liquid, we find life. And so then the question doesn't become, are there places that are kind of like the surface of the Earth, deserts, forests, whatever, on Venus or Mars or Jupiter or whatever? It's that, is there liquid water in one of those worlds? And on Mars, the answer is maybe. There are conditions that could be liquid water on Mars. But on Europa, the answer is almost certainly there is a large ocean of liquid water underneath the ice. And then the same thing is probably on Titan. Although, some people think maybe Titan, the interior of Titan, isn't an ocean of liquid water, that maybe it's slush. But even slush can have life in it. But then we also suspect that there are these oceans of water on many other worlds. All of the large moons around Jupiter, except for Io, so Ganymede, Callisto, and Europa, Enceladus at Saturn, but even Triton going around Neptune, some of the big moons of Uranus. Pluto could have oceans of liquid water underneath the surface. And so then, if we know that there is water in those places, and if there's always life on Earth, then those make sense as the places for us to search. And so far, we have not adequately searched them. So we just don't know the answer to that question. The most accessible place that we could probably get to is either Mars, if we drill down in some place where we suspect there's liquid water under the surface, or Enceladus. Enceladus is that moon of Saturn, which is spewing water ice out into space. We can detect hydrogen gas mixed in with that water vapor, or the frozen water vapor. We can detect various organic chemicals mixed in with that. So all the kind of raw material for life and the food for life and the water is there, but is there actually life? We still don't know. And this is the big mystery right now that astrobiology is facing. Because if we do find life on one of those worlds, we find life at Enceladus, if we find life under the surface on Mars, then the next big question is, are we related? So was there some precursor organism that maybe lived on Mars and was somehow made its way over to Earth, or vice versa? Would all the life in the solar system be related? That would be a question. And if it does have DNA, we could probably find a common ancestor. Maybe some number of billions of years ago, something split off. Some of it went to Mars and some of it went to Earth. Gadzooks, if Venus had a moon, would it be any different? Probably. Venus is very different in the solar system in that it has rolled over upside down. So the axial tilt on Venus is 177 degrees, which is effectively completely upside down. It is turning backwards from the direction that the rest of the planets are turning, and very slowly. And one of the explanations for this is that Venus just never had a large moon, the way the Earth has a large moon. And the moon has probably regulated the axial tilt of the Earth, stopped the Earth from rolling over, because it's like an outrigger, right? When you have a boat and you have a pontoon out the side of your boat, it is keeping your ship from tipping over. And the moon sort of has performed that service for the Earth, and Venus doesn't have that. And so it's possible that Venus rolled over because of a lack of a large moon. But it's also possible that Venus rolled over because it was impacted by a large moon, or because it was impacted by another planetoid. Like we think about the collision that caused the Earth and the moon system. Maybe that happened to Venus as well. And without a large moon to form afterwards, it just rolled over. So there's still a lot of mysteries about Venus right now. And that's one of the reasons why we want to be able to send spacecraft back to Venus to explore it and understand its internal structure. Maybe just it is unbalanced in a way that caused it to roll over like that. James Deanne, what's the max atmosphere the moon could hold on to, ignoring solar wind, would be comparable to Titan? It just depends on how much gas you want to create at the moon. So the atmospheric pressure that you would experience on the surface of the moon would just come down to how much gas is present and available. The atmospheric pressure on Titan is greater than what we experience on the Earth. And so even though it is a smaller moon, less gravity, it has more atmosphere, and so it is thicker. And then, of course, you look at Venus, right? Venus, it's like 93 times the atmospheric pressure down on the surface of Venus. So you can have a wide range. So if you were willing to just throw tons and tons and tons of atmosphere onto the moon, eventually you would end up with something that is denser. I'm sure the very limit is once you get out of the Hill sphere of the moon, sort of the point where the Earth's gravity takes over objects orbiting around the moon, that would be your limit. But that is a very big distance away from the surface of the moon. So you could make a very dense, thick atmosphere around the moon if you wanted to. I'm not sure why you would, but you could. It's time to shout out all the new $5 patrons and above: Laura Waits, Michael Sparks, Robert Sean, Charlie Holt, Nick Brokaw, Greg Long, Rob Keown, Neil Kimber, Boilermaker23, and Nathan Armstrong. Join the club at patreon.com/universe today. Storm Krow, I work with both university level and high school level students that build competitive robots, and they've asked me about a career path that would lead to working on projects like James Webb or the Extremely Large Telescope. Yeah, I mean, I think it sounds like your students are on the right track working on robotics. When you think about a modern space mission like James Webb or the Extremely Large Telescope or the Habitable Worlds Observatory or the Large Interferometer for Exoplanets, these missions are made up of a bunch of pieces. So you have the flight side of things. So the hardware that actually puts this telescope out into space. So that's an aerospace engineer. People who are designing the rockets, working on the upper stage, working on the aeroshell, working on all the parts that can get these things out into space. And then you have aerospace engineers working on thrusters, things that are going to allow the spacecraft to maintain its position in space. Then you have avionics. You have people that are working on in electronics. You have communication systems that are sending information to and from the spacecraft. You have hardware, people working on actuators, on instrumentation. You have people who are working on the optics systems that they specialize in telescope mirrors and being able to get like a perfect image on that. There was a great interview that I just did with the architect, Lee Feinberg, for the Habitable Worlds Observatory. And he talks about a lot of the kinds of things that he's working on. So, and then, of course, there's software people. You need software engineers to tie all this together, to be able to write the code that makes the spacecraft do the things that it's supposed to do. And so any STEM trajectory that your students are going to want to go on, like they're going to want to go to university, and they're either going to want to go into software engineering and specialize in aerospace or mechanical engineering, or they're going to want to get their physics and their astronomy to be able to sort of understand the underlying math and physics with this. And then they're going to want to target things like the European Space Agency or NASA or various aerospace firms to be able to get their early careers. And then at the same time, like this kind of experience working on robots is fantastic, right? Just like this practical experience. And this is the incredible revolution that we live in today. You can go onto YouTube and you can see people making incredible things in robotics. You can go and buy an Arduino or a Raspberry Pi. You can buy actuators. You can buy all of the parts that you require. You can have AI help you understand and how to kind of put it all together, or at least what are the various bits and pieces to help you write the code so that you can make practical things happen in robotics. And the more of that experience you have in your personal time, in addition to you getting the right amount of school, those careers are there, and there's plenty of work out there if you're willing to go for it. Yeah, that sounds great. Phoenix Warp 1. When our sun goes red giant, we on Earth are toast, but would that exercise in heat put Jupiter or Saturn into a more habitable zone? Yes, when the sun becomes a red giant, which it will do in about 5 billion years from now, it will expand outward. It will gobble up Mercury. It'll gobble up Venus. It may or may not gobble up Earth, but it doesn't matter. Earth will be toast. It will be burnt to a cinder. It will not be a place worth living on. But the habitable zone will expand out to 7 to 16 astronomical units, which incorporates Jupiter. And so Jupiter's moons will melt and they will be in the habitable zone. And so you will be able to go out to Jupiter's moons and just swim in them like an ocean. Although you will also still be under the intense radiation from Jupiter. It'll be a very bad day. But still, yeah. The export. Do quasars have a habitable zone? So everything has a habitable zone. Right? Anything that is giving off radiation is going to be giving off radiation so that things in their vicinity are receiving that radiation. They're receiving it as and things that are very close, the temperature they're going to be experiencing is very high, and things that are very far, it's going to be very cold. And there's going to be this sweet spot where things are where liquid water could be on the surface of a world and be melted, right? But when you think about a quasar, we experience a quasar as this quasi-stellar object. It is this very bright star-like object that is seen at high redshifts, very, very far distances. And that is because we're looking at a jet that is coming off of this actively feeding supermassive black hole. Black hole has accumulated a bunch of material. The material is swirling around the black hole. The magnetic fields around the black hole have collimated these jets of material that are coming out the poles of the black hole. And if we are looking right down the throat of this, that's called a blazar. And if we're looking like a little off to the side, that's what a quasar is. And then if we're looking at it edge on, that's called a Seyfert galaxy, because we're not seeing the central black hole region. We're seeing the dust that's around it. So you only experience those in radio waves. But the accretion disk around the black hole is kind of like the interior of a star, because this material is piled up. It's very hot, high pressure. You've actually got nucleosynthesis that is happening inside the accretion disk. And so it's like a star. And so it's giving off enormous amounts of radiation. And so at a certain distance from that accretion disk, you're going to have the amount of radiation be comfortable. And you would be able to have a planet, as long as it had like a nice geomagnetic field to stop the radiation coming from the vicinity around the black hole, yeah, you would have liquid water on the surface. Now, it depends on the mass of the black hole. It depends on the amount of material that's in the accretion disk, the temperature of the accretion disk, but absolutely, anything that is giving off temperature, like extreme amounts of temperature, is going to have a habitable zone. There's a habitable zone around white dwarf stars. There's one around neutron stars, and there would definitely be one around actively feeding supermassive black holes. Did you know that you can watch the same video with no ads and get a bonus question over on Patreon completely for free? And we call it Q&A Plus. This week's bonus question is: transpirational cooling better than a heat shield? I'll put a link in the show notes. All right, those are all the questions that we had this episode. Thank you, everyone who asked your questions into the YouTube comments, everybody who joined me for the live show. Now, we do the live show every Monday at 5 p.m. Pacific time. So there should be an event here on the channel for that next episode. I'm going to talk about sort of the amount of content that we produce and try to get some of your feedback. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrea Pedretti, Barely Griffin, Brian Bodie, Caradon, Chuck Hawkins, Commander Bela, Cooper Darkfinger, David Gilton, David Metz, Evan.Pro, Greg Feely, James Clark, Janet Smith, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, Marcel Smith, Michael Purcell, Nordspace, OneStepForAnimals.org, Rink Haidu, Richard Williams, Sean Sargent, Team Fathom Money, Team 49, Telescopes Canada, Vlad Chipelin, Wolfgang Klotz, and Zeldaborg Galactic Defender, who support us at the Master of the Universe level, and all our patrons. All your support means the universe to us. So I got a message on YouTube recently, and I just wanted to read it out and then sort of get your thoughts and feedback. Kick was here. What I'm going to say about the interviews may be a bit heartbreaking to hear, and I apologize for it, but I think I'm probably not the only one in this case, and you need to hear it. You're producing too much content, Fraser. Every time I watch one of the interviews, I enjoyed it. There is no quality issue here. Thanks for them. But I have basically enough bandwidth to watch Space Bites in a given week. Even Space Bites, I usually watch in 2 shots. My YouTube time is while I'm eating. It probably doesn't matter, though. The fact that you're producing all these interviews of scientists answering questions is worth it for anyone for the science archives. So I always sort of like am worried that we are producing too much content. You know, we do 2 QAs, we do the Space Bites, and then we do 1 to 2 additional interviews every week. Plus we do the 2-hour live stream. And then we can occasionally do other live streams and other stuff, special videos as well. And, you know, we always have this argument, myself and Anton, my producer, like, are we walking the line? Like, whenever we come up with a new idea for some new video that we want to do or a whole new series, we're like, oh, is this too many things? And then I watch people watching Twitch where they'll just put it on for like 8 hours and they'll just watch someone reacting to content just for hours and hours and hours, or even like people watching AI streamers or people with avatars. And so I'm like, no, there is capacity for a lot of content. And I totally understand if it is too much content for some people. I think if Kik was here and said, well, I'm concerned about the quality, that I don't want to listen to the interviews, I don't enjoy the question shows, I don't like Space Bites, like what you're doing is garbage and you're producing it at a astronomical scale, then that would be a problem. But if we're like producing too much quality content and people are having to pick and choose, that's okay with me. For some people, they have the bandwidth. You're doing some job outside and you just want to hear something to keep you entertained. And why not fill your mind with science and knowledge, and you can actually watch journalism done in real time. But for others, you don't have that kind of time and you just have to sort of pick and choose. And then that's what Space Bites is for. It's like, let's boil down everything that's happened this week into about 20 minutes and then like watch it at double speed. And then you only spend 10 minutes. So my hope is that we can kind of handle both of this. As long as we produce good content, then we can produce a lot of content. And that, you know, we will find out what are the very limits of this, and people just stop watching stuff or complain about the quality. And so far, you know, we don't get a lot of complaints about the quality. Sometimes I worry about the quantity, but I would love to know, like it's weird. One of the things that we did recently, which made the biggest impact, was we put the live streams live. We previously have been making them unlisted. Now we just leave them live. They're 2 hours long and they are getting as many views as, in some cases, Space Bites. And I don't understand, right? It's a 2-hour long video. And yet I think clearly there's like this place where people want to have some large chunk of uninterrupted speaking with no ads that they can just put on in the background while they're doing something else, or are actually wanting to catch up and watch the live stream. There's something special about that live experience. I don't know. But I would love to know sort of your feedback. Is it too much content? Not enough content? Is it bottomless? You could just, you know, we could produce 3 times as much content and that would be fine with you as well. Please let me know. All right. We'll see you next time.